I now believe we are going to hand over for our first session of the afternoon to our wonderful chief engineer, Meir Yacobi. Meir, can we get a wave and confirm you are ready to go?
I'm ready to go. Can you hear me?
Perfectly.
Great. Okay, I will start by introducing myself. My name is Meir. I'm an electrical engineer. I worked for Innovation Africa for many years. Until not very recently, I personally met, I think, every employee of Innovation Africa in each country. I'm afraid that is no longer the case due to Corona, but mainly due to tremendous growth over the last year. The number of employees has grown dramatically, so we need to live in Africa in order to meet all the employees. But I will get to meet every one of you for sure in May. By the way, I think we should get a bigger hotel because by then probably we will be 200 and not 100. So Sivan, notice that. I will share screen now and start the presentation. Oh, wait a minute. Share screen. One. Okay.
Just so you know, it used to be only me, Meir, Rabs from Uganda, and another employee that she's no longer with us. We used to be only 4 or 5 people. Meir has been with Innovation Africa of over 8 years. So many of the awards that we have been received, everything that you see, actually Meir has developed it. So I'm sure you're going to be enjoying the next presentation. Thank you, Meir, for everything you've done for us. Thank you.
Sivan can make you feel important and stressed at the same time. So thank you, Sivan. Okay, I will start. The presentation today is about the role of our electrical engineers, the supervision role of our electrical engineers in our solar projects, what we call solar project, meaning the clinics and the schools. The agenda of the presentation, we have divided it into 5 stages, logically with the flow of the project. And under each stage, we have the different steps the electrical engineer must take. We start with the system design, then we go to the BOQ approval, then the system installation, final system testing, and ongoing maintenance. That's the last part. Okay, we will start. We will start actually by a short introduction to understand the challenge that we face. So in the next 5 years, we are supposed to finish 500 solar projects. It's actually a very big number. When I looked at it, when I got the table and looked at it, I realized that this is a lot of projects. It's 100 projects every year. This year we need to do 75, but it's a big number. And we really need to be in our best shape in order to achieve that and to do it properly. Someone is not muted? Okay, great. I'm continuing. Currently, what we do, and we will keep doing that in 2022 for sure, and maybe later, we're sending the energy boxes and the mini energy boxes from Israel. We send them over pallets. This is a picture we took over a shipment that we sent. I think it was Malawi, I'm not sure. But you can see it holds the energy boxes and the mini energy boxes. We ship them via airplanes and they arrive to the country. Our contractor or in-house team are responsible for claiming the goods, releasing them, storing them in our offices, and installing them on sites when it is needed. Another thing, we are sending kits, what we call the energy box kit and the mini energy box kit. Every kit of an energy box includes the energy box itself, 1 metal bracket, and 30 LED light bulbs, 16 18 watts, 6 of 9 watts, and 8 of 4.5 watts. So every kit for the energy box includes what you see here. Best practice for Innovation Africa, once we power the clinic or the school, we also power the homes of the medical staff or the teachers, the nurses, the headmaster, the doctors. because the area where we operate, as you know, we usually arrive to places where there is no source of energy, no source of electricity, and we want to incentivize good professional people to work at the healthcare facilities and to teach at the schools. So one of our practices is to power their homes. It's a smaller version of the energy box. It's a bit different, and we will discuss that in a few slides. It also comes in a kit. The kit includes the energy box itself, a metal bracket, a wall bracket, 3 light bulbs of 9 watts, and 2 light bulbs of 4.5 watts. That's the mini energy box kit, okay? Okay. The last part of the introduction. Our electrical engineers, in-house electrical engineers of Innovation Africa, are responsible to assess facilities or prospective projects, what we call, to suggest the system design and to supervise the installation. I might mention here that for the energy boxes and for the solar projects, in many countries, some of the countries at least, we are already do everything in-house, meaning that our in-house electricians are doing the installation of the energy box, the solar panels, everything. So basically, it's not the aim of this presentation, the supervision, it's actually the standard for the performance itself for our in-house electricians. Okay. So we are starting with the first stage, and we'll go over all the steps. You have the load assessment, the diagram creation, solar panel selections, solar panels positioning, mounting structure, EB specifications, mini EB specifications, wiring, socket switches, light bulbs, and refrigerators if it's a clinic, and laptops if it is school. Let's now go into each stage in more details. By the way, as Sivan mentioned before, these presentations are not for the electrical engineers. The electrical engineers have a much in-depth presentations. It's for all of us, all of the non-electrical engineers personnel. I think also that basic knowledge in solar energy, how it works, how it operates, it's something very crucial for Innovation Africa employees. Excuse me. I think you don't need to be an electrician in order to understand how a solar panel works and how a battery works and the basic concept when designing a solar system. I think everyone should understand it by the end of the presentation. If not, probably I wasn't a good teacher during the presentation. So tell me at the end. The first step after a project is become prospective project is a site visit by our electrician. We call it the facility for needs assessment. Basically, it travels between all the buildings. If it's a school, usually it has classroom blocks, it has toilets, it has offices. If it's a clinic, it has the different buildings of the clinic. OPD, maternity ward, he visits all of them and he assesses the distances between them, their sizes, how many rooms they have, and what are the electrical appliances required, okay? In order to do that, we have a table on Excel spreadsheet that we will need to fill. I will link to it after the next slide because also in the next slide we are using this spreadsheet. Okay. After this visit, our electrical engineer come back to the office and he's doing a load assessment. Basically, load assessment is making a list of all the facilities and for each facility, the electrical consumers. Mainly, you can see since the energy box includes light bulbs, so for sure, it's placing the light bulbs in the different facilities according to the operation, assessing something that he had to do in the prior visit, assessing the working hours, and then calculating the needed load. It is not only light bulbs, it could be also vaccine refrigerator, laptops, and other electrical or educational appliances.
And Meir, just to make sure that everyone understands, yes, when you're saying facilities, you're actually saying rooms, because once the electrical engineers goes to the school one of the job, what he has to do, like you explained, he or they have to understand how many classrooms do we have, how many of them we would like to power, how many staff homes do we have, how many boarding places do we have, and then they're going to come back and use the following Excel to put together the number of classrooms and how many light bulbs do we want to install and where.
That is correct. I will click over the link. Let's open it. Hopefully it will explain. Okay, so you see this Excel spreadsheet. For each new project, you should download the template, rename it as the project name, and this is part of the design. You have a load assessment. This is the list of building to power. If you have more, you can add them, and you can list all the appliances and working hours. Again, this is something very general. You don't have to go into very specific details. This is for you when you come back to the office to remember what you saw and what you need to design. Then you go to the consumers list template. And also here, you will always have a list template example where you can see the OPD, maternity, both are getting the EB system. The EB system power both of them. In the OPD, you see light bulbs of 11 watt, number of units, 12, okay? You see light bulbs, 7 watt. These are not the light bulbs we use at the Energy Box kit, but these are general light bulbs, but it's the same, meaning if you are using an Energy Box, then here it would be either 9 or 18 or 4.5. The gray cells you don't need to fill, they are getting filled automatically, meaning that for each electrical consumer, you need to put the power, the number of units, day hour, night hours, and all the rest get filled automatically. And you see that if it's an Energy Box, and we will see in a few slides also the specification of an Energy Box, and you will learn to know it very well, you will know if it fits the needs, and also for the mini Energy Box. So you fill in the template, you fill in the load assessment, and you submit it with the project name. Once doing that, basically, we finished another step. The next step is the diagram creation. Again, we have a template on the shared drive, and for each project, you will download the template, rename it as the name of the project, and create the schematic or the diagram of the projects. We would like to see every building on site. We would like to see the direction of the north, so it will help us to align the solar panels. We would like to see the distances between homes. So you see the distances. That way we know if you can use a single solar system or we need multiple solar systems, so you also have the distance. Later, you will position the solar system and the Energy Box. The Energy Box and the solar system, solar panels should be positioned at the same building, usually the main building or the building will consume the most amount of energy. For here, you see a mini Energy Box and its solar panels. By the way, let me click on the link. We don't see it here. So here you see, you have also a template. Once you download the file, oh, wait a minute. I don't want to take a tour. You see a template, and you see this is an empty diagram. You have here solar panels, electrical wires, Energy Boxes, mini Energy Boxes, and distances. You use all of them to create the diagram. You have the project name, type, country, and design by. You fill everything. You copy paste them and create the diagram. By the way, you can see the orange lines are electrical wires. When you see such a diagram, when I get such a diagram, I immediately understand that we have a solar system here that serves also the maternity. Okay, it is located here on the OPD and it serves the maternity. The 400-meter Guardian shelter on this design doesn't get electricity. Is it good? Is it bad? I don't know, but on this design, this is what we did, and we need to sit together and approve or fix it. Okay, we finished another step. That's the diagram creation. Next step, solar panel selection. Ben has mentioned that also on the solar on water presentation. Why we are looking at the tier 1 Bloomberg list? It's from practical reasons and for us to use high quality standard without having too much headache of getting good solar panels. The Bloomberg list is a list that every quarter they created. It's like the best 30 or 40 top manufacturer of solar panels. Every quarter you have a new list, but at the end of the day, if I look at the list of quarter 1 of 2021, I can still use it. It doesn't vary a lot. So we are updating it every 6 months, every year. We don't need to update it more than that. But you have a list of valid manufacturers of solar panels. Why we are giving so many options? Simply because from operational purposes, we are working in 6 countries, in multiple areas. We do not have all the brands available in every country. Also, sometimes we have an available brand at a certain country and 6 months later, it is no longer valid. So we wanted to give an option, a flexibility for the contractors or electrician on one hand, but on the other to keep the standard very high, okay? The power here, again, it is something, also Ben mentioned it, we gave a range of wattage. The range of wattage, simply the bigger the panel is, it is more efficient. The size to the wattage production, it's better. Also, as time goes by, when I start working in Africa, I didn't find any 250 watt solar panels, or it was 150 and below, 120 watt solar panels in water projects. Uganda, 6 multiple 120, I don't know if some of you remember. Today, it's very hard to get small solar panels, not that we want to, but it's very hard to get them, especially for high quality brands. High quality brands only have a high range of wattage. I wrote here 275, 330. If it's 350, 340, 360 in the future, it's also okay. It's no brainer. Only thing that it is important mentioning when you do the design and when you pick the brand, all 4 solar panels must be identical, meaning you cannot use not even the same brand, but the same type, meaning if I use the brand 275 for 3 panels, I cannot put 295, the 4th panel. It is also very critical for water projects. When you put solar panels in array or in parallel, all of them needs to be the same type. I will explain in a few slides. Okay, we don't need to click on the link. It's just the same. You know what? Let's go back. I didn't mention that. For the energy box, again, one of our goals is simplicity of design. The design is very simple. And currently, for our energy box, we are using 4 solar panels in the range of 275 to 330. As simple as that. 4 solar panels, no 2, no 3, no 5, you put 4, okay? For the mini energy box, the range of wattage of the solar panel, we are using 1, and it should be between 120 and 160 watts. We have encountered an issue that low wattage solar panels, you don't necessarily get good brands. So it's a problem. We are aware of that. And if, for instance, you want a Jinko, a Trina, or a JA, you don't have a 150 watt solar panel. They no longer manufacture it. So it's a well-known issue. I would say try to advance things and to see if you find a good brand on this list of 150 watts and you see it is available on your country, contact us. We can buy a lot in advance and keep it for the entire year. We know exactly how many projects we are about to do in each country during 2022. It's not a problem to buy everything in advance if it is justified. Next. Okay. As I told you, I decided to explain a bit about solar panels, photovoltaic panels, or solar energy in general. I think it is very important for the non-electricians of Innovation Africa because the core of Innovation Africa is using solar energy. Everything we do, we are using solar energy. So it's very important to understand this subject. It's in the core of what we are doing. A solar panel, basically, it's a structure, a frame, compound from solar cells, a lot of solar cells which are connected in parallel and series inside. The solar panel converts solar radiation directly into electricity, meaning you don't need nothing in between, you don't have moving parts, nothing is moving inside, you have solar radiation absorbs inside the solar cells transform it into electrical energy, and this electrical energy is being drawn out of the solar panels by its two terminals, the plus and the minus, okay? This is a sticker I took for a Suntech solar panel because this sticker, it's basically almost the same sticker on every solar panel. It's written here the electrical specifications and also physical specifications as weight and length and width and all the maximum or the optimal operation information for this solar panel. Now, for each solar panel, we need to know three things, three very important parameters. The first one is the wattage that the solar panels manufacture. And without getting into too complicated details, you have here, you see the maximum power, 280 watts. So this is what you need to know when you analyze a solar panel, the total wattage that it generates under perfect conditions of sun. You have optimum operating voltage. That's the second important parameter. And you have the optimum operating current. By the way, the power equals to the voltage multiply the current. That's in electricity. It's a basic connection in electricity. Power equal voltage multiply current. So these are the main three parameters you need to understand for each solar panel. Why it is important to know the voltage, why it is important to know the current and the power. We will discuss that in a minute. Okay. Another thing to consider, when you get a solar panel, it comes with the two terminal outputs, two electrical wires with the plus and minus voltage of the panel. You will always, at the ending of each wire, always you have an MC4 adapters. MC4 adapters, it's the standard connection method to solar panels. One of them would be of type female, and that would be the minus, and one of them would be of type male, and that would be the plus. And you will always connect or make sure that the contractor connects the solar panels using MC4 endings on the wires that he connects. I think by now all of you should have a crimping tool kit. I know that I sent to many countries. I'm not sure to all of them because I think in some you might already had. If not, please let me know. At the beginning of this year, we will send everyone a kit of a crimping tool. The crimping tool, it's a tool to make MC4 endings for the wires, meaning that when you have electrical wire and you want to connect it to a MC4 ending, either a male or a female, you need an MC4 crimping tool, okay? It's a special tool to make endings of the wires. That way you can connect them to the solar panels. The reason is because this connection lasts much longer and it doesn't lose energy on heat or on loose connection. That's the standard best way to connect, and we are using it in Innovation Africa. We spoke 2 slides ago about the solar panel, and we spoke about 3 different important parameters each solar panel has. It's the total power it generates, measured in wattage, the output voltage that it generates, measured in voltage, and the output current it generates, measured in ampere, okay? I told you also that basically a solar panel is made out of a lot of solar cells which are connected inside in parallel and series. This is also true, this topology is also true when you want to collect multiple solar panels. In most of the cases, you will not use a single solar panel, but a number of solar panels. Now, you can connect solar panels in 3 different ways. The first way, it's a series connection, and it is exactly as it is on this diagram. You have the minus here of the first panel, plus to minus, plus to minus, plus to minus, and plus from the last panel going out. Now this plus and this minus are going to the charge controller or to the load or to whatever connects afterwards. It could be a solar pump, or in our case, it's an energy box. You see here on the side, for a single panel, we took as an example, a voltage of 36 volts. Again, it's just an example. It has a current of 8.4 amps and a power of 305 watts. When you connect it in series, the total power is the sum of the power of the 4. It's 1220. The total voltage, it's the sum of the voltage of the 4, meaning 36 plus 36 plus 36 plus 36. And the total current, it's a current of a single panel. Now, you remember I told you it is very important to use same type of panels. You cannot use a different type of panel when you are installing a solar array. It doesn't matter if it's water or a solar project. And why is that? Now you can understand why. Because if, for example, I replace this panel with a panel who has a lower current, meaning has a current of 7, then the total current of the entire output would be 7 as well. It will reduce the total current of the entire array since it is connected in series, and the current will flow. The maximum current will be the current of the smallest single panel. So this is an example why using always the same type of panel, and these are the electrical parameters of a series connection. That's the first option to connect solar panels. Okay? Okay. Another way to connect solar panels in an array is a parallel connection. In parallel connection, basically you take the minus from all the panels and connect it into one. This is a special adapter, but basically you take all the minus wires and connect them into a single wire, and you take all the plus wires and you connect them into a single wire, and you connect these wires to the load. It could be, again, energy box, pump, whatever. Again, we chose a solar panel with a 36 volts, 8.4 amps, and 305 watts. It's exactly the same parameters, okay? Total connection output. You see the power didn't change. Either we connected parallel or series, the power stays the same. What changed is you see the voltage. Now it's a voltage of a single panel, and the current, it's the current of this panel plus this panel plus this panel plus this one. 8.4 multiply 4. So the current is the current of all 4 added together. That's the difference between parallel and series connection. The power that you get on the output is exactly the same. The voltage and the current varies from one another, and you saw how. Now there is another way to connect solar panel, and that is the mixed connection. The mixed connection is basically connecting some in series and some in parallel. And what you can see here is 2 connected in series and 2 connected in series, and these two are connected in parallel. Again, same panel parameters, electrical parameters. The total power stays the same, 1,220 watts. The voltage is the voltage of, since they are parallel, so the voltage of a single one is 36 and 36, but you need to connect them because they are in series. So it's 36 multiplied 2. And the current, again, it's the current of 2. Now, if you remember what I told you a couple of minutes ago, the connection between power and voltage and current is that the power equals voltage multiplied current. So you shouldn't be surprised that it doesn't matter how we connect the panels, the total power stays the same. The only thing that varies is the voltage and the current. Now, why it is important? We will go into more in depth with the electricians about the characterizations and the optimizations of connecting solar panels. However, you need to understand that some of our electrical appliances that we feed with our solar panels have voltage and current limitations. They also have a nominal power to use, but you see that it doesn't matter how you connect the panels, the power stays the same. However, the voltage and the current varies. I will give you an example. If you take from the water world, not here the energy. If you take 8 panels, the same like this, and you want to feed a solar submersible pump, and you connect all of them in parallel, although you get the power, the total power of the 8 panels, the pump will not work, not even start working, because the voltage that you will feed the pump will be 36 volts, and the pump needs 140 volts to work nominally. Again, it depends on the THD, the TDH, but it needs at least 90 volts to work. So the way you connect the panels can influence rather your electrical appliances or your system will work or not. Okay? Okay. Need to remember from all of that. You need to remember everything, but the bottom line, when you select, when you connect solar panels on an energy box project, meaning the 4 panels for the energy box, you either connect them all in series or mixed connection of 2 in series in parallel to 2 in series. Parallel in series. You will not connect all of them in parallel. You will ask why, and the answer will be in the electrical specifications of the energy box, because currently you can also connect them in parallel. You should not understand what that is the case, but remember, you connect them all in series or a mixed connection.
Meir, is that because maybe the current will be too high and that can hurt some of the items inside of the energy box?
Exactly, but you ruined the surprise.
Ah, sorry about
No,
that.
it's okay. It's okay. Okay, let's discuss the solar panels positioning. We are taking it from top to bottom. I know when you build the tower, you do it bottom to top. In solar energy, we do it top to bottom. Now we are the positioning of the solar panels. There are 3 things to consider when you position solar panels. One is where you should facing the solar panels. And the rule here is very simple. If you are on the southern side of the hemisphere, you point them to the north. And if you are on the north side of the hemisphere, you point them to the south. Basically, Innovation Africa, if it's not Cameroon, it is always pointed to the north because everything is south of the hemisphere or it's on the equator. So it doesn't matter, but that's the first thing to consider. The second thing is the angle of the solar panels from the parallel ground. It means how much they should be tilted, okay? And also here, there is a very simple rule of thumb. The angle between the horizontal and the solar panel should be the same as the latitude of the location of installation. And I will show you, I have a slide to make everything simple. Basically, you know approximately what is the latitude in the area you operate. So there is no brainer. When you come, you know if it's a 7 degrees, if it's a 12 degrees, if it's a 20 degrees, it depends on which country you are. And also sometimes it varies between areas. I don't know, in countries that we work in very remote areas like Cameroon or Zambia, maybe there is a difference in the angles, but it's a very small difference. So that is the second thing to consider when you are installing the solar panels on the roof. The third thing to consider, shading of solar panels is something that could dramatically reduce the amount of energy being generated by the panels. Even a small portion of shade on a single solar panel can reduce dramatically the entire power. By the way, we can understand that now when we saw in the previous slides that you have the series connection and the parallel connection, and even a single panel, if its voltage or current is being reduced due shading, can affect the entire array. So shading has a dramatic effect on the production of a solar array. And I think the most important thing for sure, I'm not seeing anyone installing solar panels under a tree or under a lamp or in a place where you see shade. But what you need to take into consideration that sometimes when you install solar panels, it is noontime, okay? Or it is 4 p.m., okay? Or it is 9 a.m. okay? And not necessarily what you see reflects the entire hours of the day, meaning you installed it in the morning, but you didn't notice that from 4 p.m. you have shade coming from some obstacle. So it is very important when designing and placing the panels to take into consideration that the panels are not shaded for the entire day. Okay? Great. This is to make it simple. As you can see, you can even print it and glue it on the wall in the office, and you can see the latitude lines, and you will know the right angle, again, a rule of thumb, and you will know the positioning of solar panels. It is not something you need to design every time. Again, you need to understand it for a certain areas one time and just make sure that the contractor follow the guidelines, or if the electricians of Innovation Africa do the installation and design, they do it accordingly.
So Meir, just to simplify, can we say that in most countries, the solar panels should be facing north, except maybe Cameroon?
Yes.
What about Uganda? Uganda is right there.
So Uganda, it's on the equator. So on the equator, it's like this. It's no
flat.
Angle, it's flat. Uganda is the best from that. It's just flat.
From that.
Yeah.
But for the rest of the countries, meaning South Africa and Malawi and Tanzania, Zambia, the solar panels should be facing north.
Exactly.
And for Cameroon, the solar panel should be facing south.
Exactly.
Yeah?
Yes, that is correct.
Thank you.
Okay. This is again to explain why the angle of the panel affects the energy production of the panel. Basically, when the sun radiation is perpendicular to the panel, that way it absorbs the most, the panel absorbs the most radiation. In order to create it perpendicular, you need to create it at the angle of the latitude. By the way, in the future, maybe, I don't know, but it's not necessarily true for all days of the year, meaning the most optimal solar system tracks the sun in dual axis matter, meaning from sunrise to sunset, and also it varies along the days of the year. However, these are very expensive systems, mounting systems. And for our purpose, since we don't have an issue with the location to install panels, if we want to optimize, we just add another solar panel. If we see that we don't meet the needs during the changes of the day and the time. Okay. The mounting structure. As for the MC4 connectors, also the mounting structure is something that we started standardizing, I think, 1.5 years ago. And for now, I think we should only be using that, meaning aluminum rail and connectors between the rails and the panel and the rails and the roof. There is the L connection, which is used to connect the aluminum rail to the roof. There is the end clamp and the mid clamp for the panels. You should put 2 end clamps on the sides and 2 mid clamps between 2 panels. So if you calculate, you need 4 end clamps and 4 mid clamps if you put all the solar panels together. One thing to consider is what we saw sometimes when you install small solar panels, or when the contractor installs small solar panels, the frame is smaller than for the big solar panels. So you need to make sure that he has the right clamps in the right sizes. Once you know that he's going to a project to install small solar panels, like for mini energy boxes, you need to make sure he also has a small end and mid clamps, as long as the frame is actually smaller. We encountered that case a couple of times. Another thing to consider on the mounting structure, on the system design, we have an issue with the roofs. The roofs of the clinics and the schools are not strong. These are metal sheet roofs. Sometimes they get blown away. We saw that also. And it's very hard to connect the solar panels to the roof. We are depending on the beams, the wood beams, to connect them, meaning that the L clamp that connect the aluminum rail to the roof actually goes through the roof and it is connected to the beam. In some cases, make sure when you do the design, it is long enough the aluminum rail is long enough for you to connect it to the beams. It is much preferred than doing adjustments and putting a wooden piece of wood underneath the metal roof and connect the L connection. It also takes a lot of time. It's less professional and less good. So make sure the design is as follows, that you can connect the aluminum rail just to the beams. Know the distance of the beams from the project you are going to. Okay, we finally arrived to the energy box. So let's start with the specifications of the energy box. It's always the same. By the way, we have one size for the big energy box. It is 80 centimeters over 50 centimeters. The width is 127 millimeters or 12.7 centimeters. And the weight is almost 35 kilograms. So you have the dimension, you have the weight. Now there is the usable capacity, the output voltage, Let's go over that and let's see what it means. Basically, the usable capacity, it's the size of the battery, meaning how much energy the battery can store. And you see here, it's 2 kilowatt hour or 200 watt hour. That's the amount of energy the battery can store. Okay. Now, one thing to consider, there is also always the sizes of batteries and how long will they last. There is one thing it's important to mention. When someone asks you for how long the battery will last, okay, the right answer, the only right answer is once it finishes the number of duty cycles it is designed to operate, okay? And what do I mean by that? The lithium-ion battery that we put inside the energy box is designed for 2,000 or 2,500, it depends how you configure it, of cycles, okay? Now I will describe you two situations. On the first situation, you install an energy box in a project, okay? And they discharge the battery 3 times every day. They empty the battery very fast, no matter how, let's say they can, okay? They drain the battery very fast, and then the sun charges it again, and then they drain it again, and let's say they manage to do it 3 times a day, okay? You have another project, you install the same energy box, but they are draining the battery 1 time every 2 days. So again, the question, for how long the battery will last? In the first project, since they do it 3 times a day, and it's 2,500 cycles, so it's basically 800 days, okay? Meaning in 2.5 years, the battery will be fully drained and not usable anymore. That's the first project. And in the second project, when they drain the battery once every 2 days, it will last for 5,000 days, meaning almost 18 years. So same battery, one will last 2 years, one will last 18 years. So when someone asks you, or when you design a project and you want it to last longer, you need always to look and to evaluate the amount of discharge of battery every day, okay? And also the number of cycles of the battery. Okay. Power of the energy box. The power, it's the size, how fast the battery can be drained, basically. If it's 420 watts continuous, okay, it means that you can drain the battery in 5 hours. You cannot drain it in 1 hour, 2 hours. You cannot pull a lot of power or a lot of energy due to the limitations of the power that we did. We did it specifically. We didn't want the battery to be drained very fast. So it's 120 watts. Another thing to understand from that power is when you install the energy box and you see someone coming with a kettle, you know, to make tea or coffee. A typical kettle uses 2,000 watts. That's the power of a typical kettle. You can tell them, that's not the case, sir. You cannot use a kettle for the energy box. You can use light bulbs, you can use vaccine refrigerator, other medical appliances that we understand their electrical specifications, but you cannot use a kettle, okay? So this is what we take from this value of the power. Output voltage, as you know, there are DC type AC type, we are having a 230 volts AC output, okay? Single phase, by the way. Depth of discharge, 90%, okay? And why do we did that? Actually, I think it will be 85% this year. We lower the depth of discharge. This is again to enable the battery to last longer, okay? To last longer, meaning if you discharge it only 85% and then you need to recharge it, it will take you more time and you can not do as much cycles as you wish to do if it was 100%. So actually, what I told you about the number of cycles and the depth of discharge go together. Okay, another thing, it is a wall-mounted installation. As you saw the metal bracket in the slide at the beginning. We will touch that when we do the installation stage. The different components of the energy box. So see, you have the metal bracket, you have the aluminum box, you have the plastic front door, you have the charge controller, or we also call it the MPPT charger, okay? You have the lithium-ion battery, voltage protector, inverter, remote monitoring, and input and output connections. Okay, now you remember I told you previous slide that you cannot connect all the solar panels in parallel, right? And Sivan said probably it's because due to the fact that too much current will hurt the electrical appliances. So yes, that is the case. The voltage and current limitations of the energy box, it has two layers. The first layer is the MPPT, the charge controller, and it's a basic fundamental component in every solar system. Basically, it regulates and protects the charging of the battery and regulates the power that goes to also to the consumers. So that's the charge controller role. And in our energy box, we are putting an MPPT charge controller by Victron Smart Solar, and it has a maximum voltage of 150 volts, okay? And a maximum voltage and a maximum current of 35 amps. So if you go back, you will see that connecting all the panels in parallel will make you very, very close to the current limitation. And we don't want that. So this is why. There is another layer of regulation of the voltage and the current, and this is the BMS inside the battery. The BMS, it's initials for battery management system. It is something that you don't need this part if you use lead acid regular batteries like the one that are more frequent today in solar projects. But in lithium ion batteries, you need the BMS. The BMS does another regulation of the charging of the cells after the MPPT. Lithium ion battery is more sensitive. It needs an additional regulation. And the BMS protected from discharge, so it disconnected on a certain condition, and it regulates the charging of the cells according to how much energy it currently has. So taking the BMS and taking the MPPT, basically it means that you need less than 150 volts on the solar array input and less than 35 amps, okay? That's the charge controller. We are going to the lithium-ion battery. The lithium-ion battery, we said it already, it is 2 kWh. That's the storage capacity. The output voltage inside of the lithium-ion battery, again, when we say output voltage, this is the output voltage of the total energy box. It's 200 volts AC single phase. But inside, the battery has also an output voltage that goes into the inverter. The output voltage of the battery ranges. A lithium-ion battery voltage ranges a lot. It's not like a lead-acid battery, meaning that it can go all the way down to 19.5 volts and all the way up to 28.8 volts. Those are the differences. We narrow it a little bit. The MPPT charged it to 28.4 volts, not to 28.8. And this is why this will enable the battery to last longer, okay? And also, the lithium-ion battery also has a limitation of the voltage it can decrease before the BMS disconnects the battery. So we will continue after the lithium-ion battery to the voltage protector, because this component, the purpose of this component is to address exactly that issue. We don't want a situation when the lithium-ion battery drained, meaning if we draw too many power from the battery or too much energy and we don't charge it for a while, like let's say we empty the battery too much and then though it was nighttime, the battery could be damaged. So this is why we installed the voltage protector. The voltage protector enables to disconnect the battery before it goes to a dangerous place where the cells are too much empty and the BMS will disconnect the battery. That's the role of the voltage protector. It is also a Victron component, like the charge controller, the MPPT. It is, I didn't mention that, but the MPPT charge controller, the Smart Solar, has a Bluetooth capability, and also the voltage protector. It's a 60 amp smart charge voltage protector of Victron. Okay. So basically the lithium-ion battery is connected to the voltage protector, and from the voltage protector, it goes to the inverter. Why is that? Because the output that we want to give to the electrical appliances is a single phase 230 volts AC. This is why we need an inverter. It's a Victron inverter, Phonix 500 volt amps maximum, which give continuous of 420 watts. Again, when you connect electrical appliances, when people on site want to connect electrical appliances, first of all, they shouldn't. You need to understand what kind of electrical appliances they need and to tell them if they can apply them to the system, okay? But also it's important to tell them why they cannot connect every electrical appliances they want. First, the inverter has limitations. Second, we don't want the battery to be drained by highly consumed electrical appliances, and therefore there will be no enough energy for the vaccine refrigerator, for the lights, for the laptops. So that is the inverter. After the inverter, there is the remote monitoring system. The remote monitoring system, it's a cellular modem with a firmware of Innovation Africa. The cellular modem, the remote monitoring, is connected to the MPPT charge controller via communication cable. It has also a cellular antenna. It gets power from the output of the battery, meaning it gets the range of approximately 24 volts from the battery for power, for auxiliary. And he reads from the MPPT. We started by the end of this year, read actually two parameters. One parameter is the total amount of energy that the solar panels charge the battery, okay? And the second one, now we started to read the voltage of the battery, and through that we calculate the power or the energy that the locals are using, the hours and the amount of energy they are using. So we are measuring now two parameters, and it serves us for getting, first of all, the solar array and the battery charging production operation, and also electrical energy consumption.
Yes, so Meir, let me just say a few words here, if you don't mind. First, allow me to say that thanks to the remote monitoring system, we received our first UN Innovation Award back in 2013. So just so you know, back in 2013, when I presented at the United Nations and I presented our off-grid solution for remote monitoring, thanks to Meir, we received our award from the United Nations. It was truly a big deal. It's still a big deal for Innovation Africa. So again, this is all thanks to Meir's brain. So he's not only good looking, he's also very smart, very smart.
You lost credibility now.
But what Meir is trying to say, it's something that is quite important, because our donors, when they give us money for a school or a medical center, they want to know when people are using the electricity. When do they open the light and close the light? Until recently, we couldn't monitor it. What we can see on the remote monitoring system on the graph, we can see when the battery is being the battery is being charged and discharged. Yes. But this is usually happen during the day. So people were telling me what, they're using the energy during the day? I said, no, this is when the battery is now being charged thanks to the solar panels. But now what Meir is saying, that now we are also going to be able to monitor when, not only when the battery is being charged, but also when people are actually using the appliances, meaning when do they open the light bulbs, when are they using the computers, and so on. So Meir, thank you for that update. This is terrific. Will truly help our donors to follow and be able to monitor the production and consumption of from the energy BACs. Thank you.
Okay, I will say two things about it. From my experience, everything good that happened in Innovation Africa happened as a teamwork. And this case is also happened this way. So it's Jeremy and Chedva, our software engineers, due to their work, and also Sagit's effort, we are able to improve the monitoring in the last 4 months, and hopefully we will improve it much more during 2022. The second thing I will say, it is always a struggle for us to generate more information for Innovation Africa and its donors to use on one hand, on the other to keep it simple, because we want to scale. We don't want things to break. We don't want to inflate the cost. We want it to be simple, but we want to give much more information. We understand the importance of it. Okay. Okay. For the energy box, we said that now basically the maximum voltage is 150. The minimum voltage is 28.5. And why there is the minimum voltage? It's because the battery, in order to charge it fully, we aim it to be 28.4. That's the voltage of a fully charged battery. So you need the solar array to give at least 28.5. If the voltage of the array is lower than the one of the battery, it will not be charged. So you have a maximum voltage and a minimum voltage. These are the limitations. And also you have a maximum current. And you need to work under those limitations when you design solar panels array for the input of the system. Again, we went to the energy box solution in order to keep it simple, not more high quality and not better looking, but also keep it simple. So it's no brainer. You put 4 panels, you know the power of the panels, everything will fall into limitations if you can connect them correctly. To electrical appliances, we also state that 420 watts, 230 volts AC, 50 hertz. Total available battery storage here, I see I lower it to the new value. It's 1850 watt hour. It's to increase the number of years. At the end of the day, we want these projects to last, and we don't want to go and replace, especially since now we need to do 500 projects.
Meir, should we spoil the surprise by saying that as of yesterday we received, or should we not? Should we tell them that we just received the new model of the energy BACs, who just arrived to Israel after 3 months? We've been waiting from China, and the battery will be bigger. Is that true, Meir?
So you are absolutely correct. I wanted to do, Uri Shlomo was supposed to bring it between 2 to 4 to the office. So we still have time. I wanted to twist the camera and to show you what is currently happening. It's the first unit that we produced in China, energy box and mini energy box. Of course, we will have to test it a lot, but if it's good, not only bigger, but will make operations easier, cheaper, things will flow faster. We have a way to go there until it would be ready, but it's a huge milestone. Once it's land here in the office, it's a huge milestone. I will speak slowly, so I will give him time to come.
I'm calling him.
Okay. Okay, I'm continuing. Now let's move to the mini energy box. The mini energy box is a small brother to the energy box. It's aimed to be installed at the homes, as we said. What's important to know about it, you see the sizes, it's much smaller. You see the weight, it's much lighter. Its usable capacity, it's 232 watt hour. It gives 60 watts continuous power, and also it's 12 volts DC, the output. It's not AC, it's DC. One of the reasons we moved to DC on the mini energy box, it's also due to a lot of feedback from IAA electricians saying rightfully that when you give such a small battery, there are no small AC electrical appliances. Almost every appliance that you connect, which is AC, consumes relatively a lot of energy and is not suitable for the mini energy box. So we moved to the 12 VDC. Again, it's a lithium-ion battery, same depth of discharge, also wall-mounted. You can see here the USB connectors on the side. We will talk about them. It's actually 4, and it's actually a question on the quiz. Okay, mini energy box specifications. If we go now over the components, so you have a metal bracket. It's a much smaller metal bracket. Aluminum box, plastic front door. You have a lithium-ion battery, MPPT charger, and input-output connectors. Those input and output are 12 VDC regular terminal DIN rail connectors for the light bulbs, and USB 4 terminals connectors for charging phones. And also in Africa, in rural Africa, you have a lot of appliances that operates on a 12 volts USB terminal. So sometimes it could be ventilator, or it could be a radio, but that's the reason for the USB. Electrical specifications. So from the solar panel, you see there is a maximum voltage of 22 volts, a minimum voltage of 14.5 volts. By the way, the maximum voltage, we should update that value. It could be bigger now because we are using a different charge controller. So the maximum voltage could be actually bigger. The minimum is 14.5, and this is due to the reason that lithium-ion fully charged battery for the mini energy box is 14.6 volts. So 14.4 volts, I'm sorry. So you need a minimum of 14.5 volts in order to charge it. The input current, the maximum is 7 amp. You cannot go above 7 amp. The voltage, you can go a bit higher. You can go a bit higher. Electrical appliances, the output of the mini energy box, you have a 12 VDC output regular terminals, and you can take them for the light bulbs. This is mainly for the circuit of the light bulbs. You have, I don't see here the USB, but you have 4 USB terminals of 12 volts as well. I'm sorry, 4 USB terminals of 5 volts, 2 amp and 1 amp. This is to charge phones and to power other stuff, which is 5 volts, 1 amp and 2 amp consumers. And the total energy stored, you already saw that. Okay, we are going to the next step. Again, this is not in depth. It's not for electrical appliances, but it is for all of Innovation Africa employees to make sure if they are on site and they see and they look on the installation, what we are using are standard switches, sockets. We don't want improvisations. We are using junction boxes. We are using flexible electrical wires, and we are inserting the electrical wires into UPVC piping. We are going over the walls. We are not inserting the electrical wires into the walls. We are putting all of them on the walls in terms of, we don't want to start breaking the walls. These are not stone walls. But we still need not to leave exposed wires. Everything needs to be in UPVC pipes and junction boxes. This is a recommendation. I know that in terms of lighting, placing light bulbs, not every place looks the same as the other. Sometimes the size of the rooms is different. Sometimes the number of windows and their sizes and their direction is different. There is no other way for designing light bulbs than being on site, going room by room, understanding the needs and assessing where and how many light bulbs to put. By the way, sometimes also the level of light, the amount of light needs to be bigger. If it's a clinic and if it's a room that they give dedicated treatment, maybe we would like to put more lights, and vice versa. If it's in a warehouse, in a clinic, we don't need a lot of light. But saying that, especially in rural schools in Africa, learning blocks almost always look the same. I would take a chance and say they look the same. A learning block has 2 classes with 2 entrances to each class. Sometimes it has an office attached, sometimes not. So this is the typical light bulbs positioning of a learning block. You see security light on the outside, small security light. You see the 18 watts, the bigger light bulbs, 4 on each class, on the back, above the board, the writing board, and in the middle of the class. Again, it can vary. Maybe you put 1 here and 1 here. It depends, but this is a recommendation. A toilet, it's something that we need to put light. Sometimes they will ask also for a security light outside. So you need to consider that. Again, it's a recommendation of how to use the light bulbs. This is like for a full school. By the way, not all the learning blocks we power with lights. And this is, if we go back to the stage of the design and the load assessment, in some classes, they will say they do not learn at nighttime. So we do not put light bulbs in such classes.
And Meir, just a reminder, for every 1 energy box, we have 30 light bulbs.
Exactly.
Is that correct?
That is correct.
And for every mini energy box, we have 5 light bulbs.
Exactly.
Okay, wonderful. Okay. Thank you.
After,
and by the way, he's downstairs, he's coming up.
Yeah, I saw them going down to get it. After we will go over the clinic recommended lighting, I will touch what Sivan just said, and this will also be in the following days also a topic for further analysis with the electricians about the number of light bulbs. Here you see a typical clinic, with the OPD, the maternity. You see bigger rooms, you put bigger light bulbs. Sometimes you need to put more than 1. Sometimes the security light could be bigger. If you understand from the community, it's an area where a lot of people are waiting. Again, it's a matter of design, a specific design for each project, but you can follow a general guidelines, meaning you have 3 types of light bulbs, use them wisely. I will go back. I will just say now, we are sending in each light bulb energy box, as Sivan said, 30 light bulbs, and in each mini energy box, 5. Now, I encountered, due to feedbacks from our electricians in Zambia, Malawi, Uganda, Tanzania, that sometimes in certain installations, they need more 9-watt light bulbs, and sometimes they need more 18, sometimes they need more 4.5. It varies. We discussed that in our department. We decided for 2022, we are still going to be sending the kits because the kit has its value. You bring it to the site, you know exactly what you have. You don't get to the place that you open and suddenly you forgot the light bulbs. Everything is inside. However, saying that, we will be shipping more light bulbs in the 3 different sizes for each country, for the country to store in her office warehouse, and to use it wisely along the way. And hopefully in a year or more, we will be more wise, maybe to adjust the energy box kit amounts of light bulbs, or we will always work with you have the default amount, and also you have in the office more light bulbs. Always when the contractor go to install or Innovation Africa electrician go to install, put in your car more light bulbs, and spread them accordingly to the specific design. Okay. So, refrigerator and laptops. Let's speak about refrigerator first. I know now as a fact that a vaccine refrigerator, a solar vaccine refrigerator of the brand Sundenser DCR 165 is available in Zambia and Tanzania. I know that it could be available in Uganda or Malawi, or we can ship it from Zambia to Malawi. It's no brainer. It's a very short trip and we can do that very easily. Yeah, wait a minute. I don't know if to twist the camera. The energy box arrived. Okay. So we can ship it to Uganda, saying that we want to standardize the vaccine refrigerator brand for all of our projects. We don't want to reinvent the wheel every time and to look for brands. This is, I think, one of the, for sure, top best 5 brands of a solar vaccine refrigerator, if not top 3. And we decided to use it in each project. It's not only very high quality, it also fits to the energy box very good in the sense that it uses 24 VDC and it consumes 160 watt-hour for 24 hours, meaning it's very low on energy consumption. It's relatively big. It's an ideal. So we will use it for Cameroon. South Africa, I'm not sure about clinics this year. For Cameroon, we will need to discuss how to do it, if we can get them there. But in the 4 countries I mentioned, for sure, we will use the Sundenser for each healthcare facility. Okay. Yes. Maybe take a 5 minutes break. I will put the energy boxes also behind me while
Okay, good idea, Meir. Thank you. So far, very interesting. We are looking forward to see the new energy box. So let's take, how long do you need, guys? 5 minutes, 10 minutes, 15 minutes, how long?
I 10 minutes. I think saying 5 to 10 minutes.
All right.
I have to say that I did miss the Zambia photos. So when Meir finishes his presentation, we can go back over. So I'd like to give everyone just a 5-minute break now, as Sivan said. And but I didn't forget. We're going to show them after Meir's presentation. So thank you, Zambia.
All right. So 5 to 10 minutes. First, 2 energy boxes from China. So thank you, Uri. Looking forward to testing them and seeing if we will be replacing our current ones. Thank you.
Okay, we can continue now. So wait a minute, let me share screen. Tell me when you can see. Okay. Okay, I'm ready to continue. So we stopped with.
You duplicate.
Wait a minute. Okay, yeah, thank you. Okay, so we stopped with the vaccine refrigerator. We said that we are going to standardize it, hopefully in all countries, for sure in 4 main countries that we do healthcare facilities. Now let's go to the laptops. So usually in schools, we bring laptops. We wrote here a recommendation for a laptop. It's like a minimum standard or a good standard that we think it should include. A Core i3 i3 processor, a 5.6 inches screen, and a Windows 10 operating system. Basically, if it holds this and it's not a fabricated bad computer, then it's good to go. And one thing try to avoid is the usage of desktops. Desktops are not ideal, to say the least, for off-grid schools, since they consume much more energy. They are not portable. You can place them just in one location. And I know in schools, they like to take the computers out for the lesson and then returns them to the room of the principal. So they are not portable. And also you can only use them at the same time you get the power, unlike the laptops that you can charge them during daytime and then use them during nighttime, or just use them during daytime when they're already charged, and this reduce the load on the entire system. So laptops are ideal for our projects. I think currently we can even use 5 laptops in each school, as long as we use them correctly. Desktops are not preferred. Okay, let's continue. Okay, hallelujah. So we arrived to the next stage. This is the BOQ approval. So we did the system design. If we did it great, from now on, our work would be easy. We go to the BOQ approval. Again, like for the water, it is a template to be used, to be downloaded, renamed as the project name for each project. It is a relatively very, very simple Excel spreadsheet. Unlike the water, it has only one sheet, very short list. You just write the brand of the hardware materials, installation labor, logistics, everything. You don't have to fill everything. You can see here that you don't see the energy box nor the mini energy box. You do not have to fill all the components because not always you use all of them. I put here also, let's see. Yes, so you see here, we have also the charge controllers, the batteries and the inverters. And you are asking yourself why, if we are using the energy box. So we have also another topic to suggest what happens when the energy box is not suitable for a project, when it is too big. And we know it happens sometimes. Not in all places the energy box is suitable, hopefully in vast majority of them. But in some places we will need a bigger system. So we would source locally the charge controllers, the batteries, and the inverter. So this is why they appear here. Hopefully, again, in most of the BOQs, they would be kept empty. Okay. Finishing with the BOQ approval, and we go to stage 3. Stage 3, that's the system installation stage. Again, you have here, we divided it into 5 parts, and as you can see, the 5th part, it's a regular system. We address that issue if it's needed. Again, I want to say, if we did the design okay, and we followed the steps in a good manner, and we visited the site and did everything right, this stage will be much easier, both for the contractor and for our in-house electricians. We will know exactly where to put, what to put, how to put. We will know in advance all the obstacles, meaning the mounting structure and the roof and the distances between everything. So good preparation will make this stage very easy. The first thing, as you can see here, is to build the mounting structure, aluminum rail mounting structure. You can see here on the top, sometimes we are putting the mounting structure on one side of the roof, but sometimes we need to put it on the top of the roof. And this is usually when we want the panels to be facing north and the side of the roof is not facing north. So we will need to put them on the center of the roof. It's another installation, what you see here. But we will still be using aluminum rail structure, and we will need to connect it to the beam accurately. Then we will upload the solar panels one by one. What you see here, actually on the right side, on the left side, you see on the right side, you see 4 solar panels. You cannot see from that picture how they are connected, but if you do, if you want to audit the installation of the contractor, so you simply measure the output voltage and the current on the terminal's output at the room near the energy box, but I will discuss that. Energy box and mini energy box. So for the energy box, the only rule for installation, the location of the installation is, first of all, it should be under the solar panels, and both should be in the main building where they consume the most amount of energy. And you should install the energy box in a secure place, meaning a place that people will not tamper with the energy box. They can lock this room and people will not open, will not play with it, will not try to connect to it. You should also place it in a height which is above children's reach. which is more than 130 centimeters, or I don't know if it's George Bush, you need to put it at 2 meters, but 130 centimeters, it's a regular child. You see the metal bracket, when you mount the metal bracket, it has a lot of holes, okay? We wrote here, connect the bracket to wall using all holes. Now, not necessarily. Why is that? Sometimes the walls are very weak. Sometimes you drill in certain points and the wall is not strong enough to hold the screw. So this is why we have a lot of locations to drill. What you will do is mark all the points on the bracket that you should drill. You can start drill and see if the wall is relatively hard. You don't need to put all the screws. You need to put about 12 or something like that in good locations when you see that the wall is strong. If the wall is not strong, so you will probably need to use all the holes. The energy box, in order to mount it, usually you need 2 people. For one person, it's relatively hard. It's quite heavy. And also you need to do it very accurately. The easiest way we found is you open the door and actually a third person stands and look inside. The 2 people hold the energy box vertically to the wall, horizontally, to the bracket. And the third person adjusts until he sees the 4 pins up and down appear in the locations inside the energy box. You press it to the bracket and you lower it and it locks. And you should see all 4 pins are inserted inside and holding the energy box well. On first installations, it's a little bit tricky, but all the teams in Africa, our in-house teams are doing it very fast and good today.
Meir, these were great pictures. Where are they from?
This, I think Tanzania, I'm not sure. Tanzania.
Fantastic. Fantastic.
Yeah. We actually have for each country an energy box installation WhatsApp group. So we have a lot of pictures. By the way, Michal, if you are not a member of these groups, so we should add you. I heard your presentation this morning and I thought you should be added to this group because we have like every EB installation. Yeah, like 30 pictures at least for each new installation. Okay. The next step after the energy box is mounted and a solar mounting structure is connected, solar panels are connected with MC4 connectors, and the wires, the plus and minus wires from the solar array is downstairs. You need to lower the wires downstairs next to the energy box. You connect the 2 wires to the input terminals of the energy box, the circuit breaker. Now, when you will get the energy box, the charger to the battery will be disconnected, and the battery to the load will also be disconnected. This is for a purpose. We don't want the battery to be drained even by small consumers like charger and inverter. So this is why we disconnect it. Once you connect the solar array to the terminals here, also verify that the circuit breaker is disconnected and the power does not continue to the charge controller prior to that. And then measure the voltage level at the terminals and see that they are connected correctly, polarity wise. And also you can measure the voltage level and easily know that the panels are connected accurately and all connections are right. If it's a mixed connection, you know what kind of voltage to expect. One thing very important to notice is you do the installation and the checking when the radiation is good, okay? That's the best time to do it. If you do it at nighttime or early morning, it's also okay because it takes time, but at nighttime, it's a bit problematic. So take that under consideration. Okay, so first thing, you measure with multimeter, the terminals of the circuit breaker. Okay, now you connect the MPPT with the black connection to the circuit breaker, and you connect the MPPT to the battery with the yellow connection. And once you are doing that, you should use the Victron app, phone app application. It's a Bluetooth application. Every electrician of Innovation Africa should have this application on his phone. It's a very convenient analysis on-site application. It has a lot of capabilities and give you a lot of insights about how you connect the system and how it operates. Basically, you will immediately see the input terminals of the MPPT in terms of voltage and current. So you will know how much, the solar array operates, and you will see the charging rate, meaning the voltage and the current going to the battery. So you will see the total power, and you'll see voltage and current on the input and output, and it will enable you to very fast understand if something is wrong or if everything is okay, and you can continue. Okay. The next step would be, there is also the voltage protector, as I told you. The voltage protector also has the Victron app phone application. You will pick him up from the list when you open the Victron app, and you can also see that it is well configured, meaning to check voltage protector operation, it's a bit hard. You need to let the battery be drained until the minimum limit, and it's a bit hard to do. Basically, what you do, you check with the Victron application, Victron phone application on site, that the configuration of the voltage protector is accurate. This is the voltage protector. Okay. After you select, you checked the charger, the battery, the voltage protector, the next thing would be to check that the output voltage level of the terminal of the inverter is okay. Basically, you use, again, a multimeter on the terminal, two terminal outputs. You measure, you should get 230 volts AC. Also, another thing to consider, if the inverter is operating accurately, you should see a green light here. If the light is red or no light at all, it means the inverter has an issue. Another thing to consider, you see here the switch, the inverter's on and off switch. Sometimes you will come when it is off, meaning on the center level. If it's off, activate it and then measure the voltage on the output terminals. Now, when all the components inside the energy box are checked, except one, the cellular modem, the last thing to check is on the door, the battery monitor screen. If it's functioning, you will see it on. Basically, you will see the status of the battery, the percentage that it is loaded, it is charged. When we are sending the batteries to Africa, we are charging them 30%. It's due to limitation of shipping them by airplanes or boats. You need to charge them only 30%, no more. So you will expect to see this value plus or minus. Anyway, if not, you can check with the Victron phone application that the battery is charging and the value here rises accordingly. So you check the monitor screen. Last thing to check is the cellular modem. Basically, if the cellular modem, once you activate the cellular modem, the light here would be red. The cellular modem is on and is looking for a network, cellular network. Once he found the cellular network and he managed to register and to send data, the light here turns from red to green. If the light is green, it means that most chances that the remote monitoring system is working in terms of communication and is sending data to the server. So again, no lights at all. A power issue, red light, it means that it is on and you should give it a minute or two, up to 5 minutes. And once the light is green, it means communication is okay. If not, you need to play with the antenna, meaning to take the antenna out of the box and to install it in a higher place to improve communication. Okay. Okay. Now, after we checked all the components of the energy box and checked that the cellular modem is sending data, what we will need to check is that the phone application received the data and we are getting good readings from the system. You go to project management, you go to check monitoring unit, you write the project name. The project should be already registered on the web or phone application. And then you will open the project. You will see the last readings of energy and voltage. As I told you, we are also reading voltage values now for each project. So you will see a counter of energy. If you see that now the sun is shining and the battery is being charged. You can see that with the Victron phone application, it means that the counter value should grow. And it should grow accordingly, according to the power that you see. If, for instance, you see 600 watts of power being charged to the battery, so every minute you should see 6 watts being added to this counter value. Also, the battery is level. If the battery being charged now, you see it rises. And if it's discharged, you connect the load, it should be reduced. So you just have a quick understanding if the system operates in terms of charging and discharging, and we are getting good readings to the application. Nothing is switched or not well defined on the software side. Last, to check, to install, you install an earthing system and a lighting arrestor on the roof. The lighting arrestor should be connected to the earthing. The connection of the earthing should be as close as possible to the room with the energy box. Hopefully on the wall of the energy box on the outside, you should do the earthing. You use the rod, you bury it in the ground with cement, you connect the lighting arrestor to it using a bus bar. It's not a bus bar as we saw on the water project. It's merely a simple, it looks like a circuit breaker, a merely connector that connect the lighting arrestor to the earthing, and that way we will deliver all the excess energy in case of lightning strike to the ground, and it will not damage the energy box or the solar panels. Okay, light bulbs. As we've seen on the design, now it's you install all the light bulbs on the ceilings and on the walls. You can place them on side walls if it is above the board, the writing board, or if it's in corridors, you put them sideways. If it's security, you put them sideways. If it's inside of classes and rooms, hopefully you put them on the ceiling. You wire them. Again, all the wires need to be encapsulated with UPVC tubes, and each room should have its own separate circuit breaker switch. Okay, a separate switch. We do not want to put to get stingy on switches, or the contractor will be stingy on switches, and that way we turn the lights in a non-efficient manner, meaning you put the light bulbs inside the class and the security light on the same circuit and on the same switch. And that way, they both needs to be always on or off. So it's very important in each room to separate the circuit and the switch from other rooms and electrical appliances. Okay, we spoke about the regular solar system. We mentioned that a few slides ago.
Again, Meir, just so people understand,
yeah,
we want you to use the energy box and the mini energy boxes. If you need even to use 2 energy boxes in a project because the school is so big and we have so many classrooms, or maybe because the health center is so big and we have so many different rooms, it is okay to use 2 energy boxes. It is okay. But what Meir is about to show you is that in case you do not have energy boxes and for some reason you can go ahead and install what we call a regular solar system. Everything you can buy locally. So go ahead, Meir.
Yeah, so as Sivan said, there are 2 situations where you will not use energy box. One is you want to meet your goals, and don't want to hurt your bonuses, and because of me, you do not finish projects and you will not get bonus. Exactly. I don't want that on me. Okay, exactly. I will try this year to ship as fast as I can. That's the first situation. And the second one is sometimes, and it's not a regular situation, you will have a project, then they will specifically tell you that they have a medical equipment that consume a lot of energy and need a lot of power, and they really want to use it and they already has it. So in such case, for an example, you might want to design a regular, what we call solar system. Basically, it means solar panels and mounting structure you source locally as we did before. But for the system itself, meaning the MPPT charge controller, the lead acid battery, and the inverter, and the circuit breakers, and metal cage, all of that you source locally, and it would be from, we already have a approved brand list for all of the countries. We can separate that according to what we have specifically in each country. So if the contractor or you, our in-house electrical engineers, need to select, you will select from that list. So we will know that the components are high quality.
Meir, why did you write lead acid gel battery? If they can find lithium ion battery in their countries, would that be better?
You are right. Yeah, it's also an option.
It's also an option. Okay.
It's also an option.
Yeah. All right, let's continue.
Actually, as time goes by, things are becoming more and more available in Africa. And if lithium ion or LiFePO4 batteries were very rare in Africa today, it's no longer the case. But again, it's not popular as in other countries, but you start seeing them more and more.
Okay, thank you.
Okay. We go to stage number 4, and this is after we did all the installation, we did the design, we did the installation, we do final system testing. The purpose of that is once we finished everything, sometimes things got messy along the way, meaning you did something or the contractor did something, and then he continued and things didn't work. Things got messed and disconnected, and you want to make sure everything is working properly after you're leaving the site, and you want to tell to the contractor, work is done, it's a good work. So basically you do, again, solar panels performance, okay? You check the voltage level and the current using a multimeter. You also check it with the Victron phone application. It's also a very good tool to check, give you a good analysis. You check charging and discharging of the battery, meaning that what you will need to do in order to do that step, you will need to charge the battery connected from the load and just charge it and see what is written down here. You need to conduct the checks when radiation is strong, because some of the checks are for the solar array performance, and for that we need to have radiation. If it's nighttime, we cannot check that. We can check battery, but we cannot check the solar panels. So make sure, prioritize and plan accordingly that you can check when it's noon or close to noon. That's more preferred. So for the energy box performance, you charge the battery with the solar array and see that it gets charged relatively in the right amount, meaning not too slow, not too fast. And also then discharge it, meaning disconnect the battery from the load, from the panels, and make sure it is not disconnected. There were cases that there were issues with the battery, and we didn't notice that because the load gave the power and the voltage and the MPPT transformer to the consumers. But once sun was down, we saw that the system is not working. So also measure that the battery is getting discharged correctly when the load, when the solar array is disconnected. Again, check the inverter voltage level output. Also check that the circuit breaker operates. This goes both for the input and the output. Disconnect the circuit breaker, measure the voltage, and make sure it is working, meaning it disconnects the load, both on the input and the output. Okay, sockets and switches. We don't have a lot of sockets, but it's important to check that they are working. So take electrical appliance that you can bring with you. It could be a 230 volts AC light bulb or anything else. You can charge your phone even with your regular socket, but charger, that goes into the socket. But basically you need to go and to check each socket and to make sure it is not disconnected. The same goes for the switches that they connect and disconnect. And same goes for light bulbs. Make sure that all the light bulbs are okay, meaning on when the switch is on and off when the switch is off. Additional electrical appliances, could be computers, it could be vaccine refrigerator, a projector, whatever other medical appliances you bring to the site, a charging system, phone charging system, you need to make sure that everything operates, everything is okay. Okay, this is again another review that the monitoring, remote monitoring operates. Okay, first you can check with the Victron phone application that the maximum power point under the MPPT limitations are being reached, meaning that if the sun is strong now, and you know the MPPT limitations, you know the voltage and you know the current, you see that it reaches them. If it is approximately, it is also okay. If it is dramatically low than what you expect, you need to do the checking again. Maybe something is wrong. Maybe something is shading the panel. Maybe on the mixed connection, some component got loose. So you need to check that again before you go, before you leave. For the phone application, we want to see that we are getting readings accurately. We want to see the voltage levels that we read are aligned with what is going on the site, meaning that if the battery being discharged, you want to see the voltage level reduce. If it's being charged, if the battery being charged, you want to see the voltage level being raised. You want to see the energy counter advances accordingly to what the Victron application show you the charging power is. So you want to see all of that before you leave. Okay. We finished with the main 4 stages. The 5th stages is the ongoing and maintenance operation. Sorry. It's actually, It's actually a very important stage. And why is that? It is very important for Innovation Africa that the systems that we are installing will continue to operate, not for a month, not for a year, but for many years. It's also important that they will operate correctly, that we will not encounter a situation where we are visiting a clinic and 1/3 of the light bulbs doesn't work, or they tell us that they only have power for 2 hours after sunset. We don't want to reach that situations. Saying that, we need a maintenance visit by our electricians to assess that everything is okay. Also, it will enable us to understand what we are doing wrong. Maybe currently some of the things we are doing are not optimized. And without doing a maintenance check every 3 months or so, we will not be able to do that. There could be a situation where the local community abuse the system or does not handle the system accurately. There could be a situation that one of our components is faulty, things on the installation. We want the system to work for the community, and also we want to learn from our mistakes, and we also want to scale, so we don't want to go back and fix all the time. So the ongoing maintenance is a very important step. I think every 3 months is a minimum to visit the project. So.
Meir, thank you very much. I believe that many of us right now are appreciating even more the work of the electrical engineers, because as you can see, they have to do so much when it comes to solar project, but also today we have learned that also they have a lot to do when it comes to water projects. So once again, chapeau to you, Meir, for everything you have done for us and for your team, and also for all of our electrical engineers in Africa. Thank you for your work, and please continue to give us the feedback, some feedback from the field when it comes to the energy backs, because as you see, we're still testing everything. We are still trying to figure out the best version of the energy backs to produce. Okay. Questions. Tara, can you help us, please?
There are so many, so I hope, how much time do we have? And we'll get as many out as we can.
No, we do. Take 15 minutes. Let's answer those questions. Let's
fire as well.
All right. I'm going to fire as we go. Okay. So we're going to start back kind of from the beginning of your presentation. Kol hakavod, Meir, anyways. I always love when you present. Always. Okay, so Thembi in South Africa was asking, how do you choose the cable size from solar panels to the components in the pump room? It's kind of I think it's a question with the water to the solar part.
Yes, I think, look, the cable size, usually when you select the cable size, it's according to the length of it, okay? And the current that flows through it. These are the two parameters that enables you to select the right cable size. When I say size, I mean the cross-section of the cable, okay? The cross-section should be determined by the length of the cable and how much currents need to flow through it. If we are talking about our water pumps, we are talking about 10 amps. The current is 10 amps. I think 2.5 millimeter is good, but I'm not sure. I'm throwing. I need to see what we decided, like the ranges. By the way, on the cheat sheet, we have ranges of selecting the cross section of electrical wires according to the current. So maybe I can share that with everyone later.
Not yet. We're still working on that cheat sheet. It's a surprise that we would like to send to everyone by next week.
Okay, sorry.
Meir prepare it for all of you, but yes, the cheat sheet will give you many of the information that you should know, but this is after the quiz, after the quizzes. Yeah.
Okay.
Okay, Guy here had a question. He said, is there a general guidance on what percentage of the day it's acceptable to have the panels partially or fully shaded?
I would say none. The panels should not be shaded at any time during the day. The design should be as a way that the panels are not shaded at all. We will not tolerate shade. It's a waste of
so
energy.
What if the clinic is actually located within kind of trees or surrounded by kind of more vegetation?
In rural Africa, what we encountered in schools and clinics, the only possible shades in such area are trees. And if the tree does shade, we cut the tree.
It is actually something that happened to us recently in South Africa. In one of our projects, the name of the village was Go, Go, Go. That's the name of the village, Go, Go, Go. And the pump didn't work. And we were wondering why it doesn't work as well. People were complaining that they're not getting enough water. And then we sent our team from South Africa, and then we found out that there is a big tree. And so at some point we had to tell the community, we have to take down the tree. There is nothing we can do about it. Because of the tree, we don't get enough sun. The solar panels are not being used properly. And that's the reason why the pump is not working. So finally, a few months ago, we took down the tree. So that's what we have to do sometimes, unfortunately.
Okay, so we have another question. When we want to install panels to already existing buildings like schools facing the wrong direction.
So we are doing it on the center. There is in the picture, we chose actually one situation like this, and I can share more pictures that shows how to install in such case. If we encounter such situation, we install on the center of the roof, meaning it goes from both sides. We build a mounting structure on the center of the roof, and the panels are like this, facing the right direction.
Okay, does the use of aluminum structure apply for water projects? If not, why?
Water project, it's a bit different. First of all, we have the steel inside the concrete. We have a steel frame, a metal steel frame inside the concrete design. And on top of that, we use the aluminum rails. It's two different parts. We do not have where to connect the aluminum rails on the water tower, or at least we can create something, but what we did is the steel frame. And for that, we connect the aluminum rails. For huge solar arrays, it's a bit more complicated. I agree that it's a problem. We need to dedicatedly design the solution if it's a lot of panels.
Thank you. William in Cameroon asked, what do we do in the case that we installed solar panel on top of the roof of a health center and the two sides of the roof do not correspond to the good condition.
Good condition meaning facing north or south?
Yeah, it was during the period you're talking about direction. Yeah.
So yeah, so it's the same. That question was a couple of questions ago. You install the solar mounting structure on the center of the roof. I will send example like a diagram or pictures, like when it's facing the roof facing the right direction and not. These are the only two situations. So I will maybe add a diagram of it for everyone to share.
And yeah, the students are also working on something similar. Yeah. Okay, Sarah asked, actually, this is a question probably for Sivan. The community is always asking whether the energy box can be sold. Will we ever sell it?
The reason why I'm laughing is because one of the conversation I have with Guy is about the energy box, and it is truly a product that is needed across Africa. People need energy. And I want maybe Guy to answer that question, because Guy and I are now thinking about the future of Innovation Africa, the future of the energy box, and Guy has some ideas.
Yeah, thank you. So I think a short answer is that there will definitely be opportunities to make everything we do more sustainable, and hopefully help kind of like create like more profitable businesses for the communities that we help support. And with things like the energy box, it definitely feels like something like that further down the line, we would want to explore the ability to potentially license it to third parties and have potentially other vendors or agents that can lease it to local businesses and local households that are willing and actually have the ability to finance it. I think it's definitely interesting to explore, and like what Sarah mentioned was a really good indication that there is definitely like the demand for that and the need for that. And I think we're going to need to further explore and see how to meet that need.
Okay, thank you. I feel like this is a conversation, Sivan, that we've had for years now. A lot of people wanting you to sell the energy box, so make a business out of it. Okay, so Ivan was asking, is there a standard distance to maintain between the roof and the solar panel, especially depending on the geography of the area? Say it's near a lake or a mountain.
I didn't understand the question.
Is there a standard distance to maintain between the roof and the solar panel?
Between the two, meaning the height of the mounting structure?
I guess so. It's probably similar to...
No, I think I know. He's probably talking about solar water at solar projects.
Okay.
By the way, we haven't spoken about water at solar project. We only spoke about water project, a solar project, but water at solar, we haven't touched yet. For those, all of you know what we mean. We mean that we're also bringing water to a solar project, meaning that we're also using a solar pump to pump water at a school or a medical centers. And all of you have done at least 5 of them this year. So it is a new type of project. And I guess the question, Meir, is how far can the solar, let's just say that we're installing the solar panels on the roof of the medical center, but we have only found water 500 meters away. That's where we're going to install the tank. Is that okay, or is it too far? What is the distance?
I think, again, it's an economical question because to overcome the distance in terms of electricity, there are several ways to do it. You can use thicker cables. You can higher the voltage level, so the reduction will not be so dramatic, will not influence. Everything can be done. I think in such cases, which there are the unique cases, we will need to sit and brainstorm together. It will never be exactly the same. We cannot unify all solutions. Hopefully we'll have 90% out of the box solutions and 10% that we will have to brainstorm. Water at solar with a 500 meter distance, it's a 10%.
Okay. Deo has an interesting question. Can we add some simple sticker charts showing appliances usable and not applicable to guide our end users? This is a constant question when it comes to the minis, what appliances can't be used, etc. So
yes.
what's our forward?
Yes, the answer is yes. That could be great. If we visualize on a board or on a paper or on a sticker next to it what not to use, that could be great. It will solve us some headaches. It would need to be styled, but yes.
Samir, maybe that could be one of the workshops you can do with the electrical engineers on day 5, where you can decide what type of appliances we can allow people to use when it comes to the mini energy bags and what is not. Yeah. And then we can create those stickers or that kind of visual form. Yeah. So we can provide.
I agree. We can understand what is typical appliances in each country, and then we will make a list of good and not good. I agree. Yeah.
Definitely, this is a subject that has to go hand in hand with sensitizing the community from our end. It's definitely an important point. Yeah. Okay, so another question is Eric asking, the percent charge indicators on most of the EBs don't display the actual charge levels of the batteries. They normally have a limit detection up to 75% maximum, even when the batteries are full. Oh. Is it possible to include a simple system? Okay, so that's one question, I guess.
Wait a minute, it was on the mini EBs or on the EBs?
On the EBs.
Okay.
There was another question similar about the percentage that shows up on the charge, that it seems to be inaccurate.
Okay.
Okay, that's one. And the second is it possible to include a simple system for security light control on the EBs? Since in a number of schools, majorly during the weekends and holidays, security lights are left on 24/7. That's a very good point.
Okay, great. So the two questions. The first question, I need to take it offline and to investigate. I know that there was a problem with the battery indicator, the screen for the mini EBs, because something we did to the battery, it never showed it as full, but it's no longer the case. Now the batteries comes in a different manner and it should be solved. But for the EBs, it's new for me. Eric, I will speak with you offline and we will discuss it. I need to understand. For the second question, security lights in schools, great. If there is a need, it's great. Even in clinics, it could be great. I'm suggesting we will do it as in water project, and we will pick all-in solutions, meaning a security light that has inside the panels, the battery, the motion detector, and the light detector all in one. That's the most efficient, most resilient. You buy it, you install it. It's very easy to install, and it gives you everything you need, instead of putting a motion detector separately, a light detector separately, and to power it from the battery. It's also possible, but I think an all-in-one solution, it's better also in such situations.
Why are we using AC lights, which increase on inverted power from the battery, instead of DC lights, which drain less the battery, so that AC is for appliances only?
We did it in terms of simplicity. Why is that? It's always, you always have, I don't know, thoughts where to go and what to do. In everything, almost everything in life and in engineering, you have advantages and disadvantages on everything you pick. On ours, we decided that we want AC energy. This is what we said, we want the output for the energy box. That is one. Then we said, okay, if we give both AC and 24 DC, there will be a lot of mistakes. They will connect the AC to the DC and vice versa. So in terms of these wires are only the DC for the lights and these wires are for the sockets AC, it would be very complicated in terms of implementation and verifying it is good, and it will cause issues all the time. You'll have 24 volts and you will have AC current, AC voltage, and it would be a mixture, which is not good. So we know that using AC, you have the reduction of the inverter and so on and so forth. But I think you have you lose some on the inversion, but since it's a higher voltage, you do have wires all along the building. So you use less on conductivity. If it's 230 versus 24. Also 24 volts light bulbs, it's more rare achieve. Try to buy a 24 VDC light bulb. It's harder than the 230 volts AC.
Tara, actually, Meir and I, we've been fighting for many years about it. He kept telling me, Sivan, the energy box has to be DC only. And I said, no, AC and DC, because most of the appliances are AC. You don't want to limit. You don't want to produce something that where people will not be able to use. You want to produce an energy box that could work for both AC and DC appliances. And this is the reason why Meir went ahead with it. So thank you, Meir. I know it's not ideal for everything, but it will make more sense in the future as we are allowing people to use more and more appliances.
Yeah.
Okay, Meir, you might have already answered this, but I'll just double check. When it comes to maintenance of the energy box, how are we planning to do it, especially on the issue of lithium-ion batteries, as we don't have them available in market and for a lot of our countries as well. Maybe it'd be a good idea after some time to receive spare batteries just in case we need to have to replace. It's a good question.
So I haven't answered it, and it would be a headache for Guy at 2022, this question. We are thinking, look, with the energy box, we are just now moving to higher numbers. This year, we're going to do 75. Last year, we did 25, I think, 24. So the numbers are growing. So far, we didn't send overhead of components to replace, to maintain. Which is not ideal even in small numbers. But in medium numbers, as we are going 2022, we must budget and plan to send for every country when we send the energy boxes for the entire year, also replacement components, especially the battery. The battery, it's more complicated because you don't want lithium-ion, you can store battery for a long time. But again, I'm not sure that's the best to keep batteries lying in the offices in all the countries in Africa. It's ideal. We will have to tackle that issue at a certain point. We are not there yet, but we are coming to meet that challenge very fast.
It is also very difficult to fly lithium-ion batteries.
Yeah.
Actually, it took us 3 months to get those energy boxes from China. 3 months, because they came via ship. No airline wanted to fly the lithium batteries. So it's very, very difficult. This is why Guy and I will be working on figuring out how we could provide to all of the countries where we operate good lithium-ion batteries, so we don't have to send them from Israel. It will make our life much easier.
Yes.
Okay, I know that we're gonna need to wrap up soon. Let Gabby bring in the home run. But Gabby was actually asking, many of the schools, she said Malawi, but to be honest, this is the case across all countries, where the roofs are very poor and often blow off with strong winds. And also they're not great for, they're not great for holding our mounting structures, etc., especially during installation. Would it be possible for IA to support these schools with stronger roofing where we intend to power?
Yes, we are working on that, and it would be 2022 innovation of Innovation Africa, how to make the roof stronger, especially at the area we install the solar panels. It's a challenge for us. Yes.
Yeah. But what would the solution be? That we would provide the roofs, or we just find a better solution for?
So currently we are brainstorming. We don't have the solution yet. Yeah. This is why it's an innovative solution. We are aiming towards, we will not supply an entire roof, but we are aiming to supply some reinforcement bars underneath to connect, and it will be stronger.
Yeah. Okay, I think we're almost done. Okay, I think Moti answered some of those. Okay, maybe last one. Done. Most EBs are installed without earthing rods. How does it connect to the ground?
We need to start doing that. We need to connect to make sure all the locations where we don't have the earthing rod, we need to install and to connect. It's not a complicated thing, but again, as for the water project, we need to make list and we need to go and fix and to make it the right standard.
Okay, I think we pretty much wrapped up.
All right. So once again, Meir, a big round of applause for Meir. Excellent.
Thank you, brothers and sisters in Africa.
We'd like to say thank you also for the team in South Africa. Thank you for your patience, because you in South Africa do not have solar projects, and yet you were quiet and you listened to everything about the energy packs. Thank you very much. Maybe in the future, maybe we will do solar project in South Africa. Who knows?
Learning curve, Sivan. Thank you so much.
On the second slide, you can see that we plan to do 30. So they listen for a purpose, for a reason.
Okay, so now it is the last presentation of today. It is all about the community and how can we make sure that the community is engaged? What do we have to do? And here we're going to talk about our field officers, which, by the way, we haven't spoken about our field officers until now, but trust me, and we all know that their job is as important as any other job at Innovation Africa, because without them, without the field officers, without the community engagement agreement, we cannot do anything. So first and foremost, we have to make sure that we are in a good partnership with the people we're trying to help. And that's why now we have the wonderful and only Deputy Country Director of Uganda and Malawi. Please welcome Gabby.
We need just 1 second and then we'll be ready.
Yes, please change the name from Meir so we're not confuse her.
Gabby has a lot of fans in the house. Hands up if you love Gabby.
Yay!
Gabby! So I want to piggyback just briefly on Gabby's presentation and share that just what we mentioned this morning. We want to see you guys in the field. We want to see you engaging with the community, engaging with the teams, being our representatives of Innovation Africa with the communities. When we showcase and when we share what we do, people are amazed at the amount of community involvement. And I think this is a really important part, both of the success of the project in its implementation, but of course in its sustainability. And I know Gabby is extremely passionate about this, and that's why Sivan asked her to present. And I also know that Gabby's teams in Uganda and Malawi do this so well. So it's testament to the strength of Mayan and Gabby and the wonderful teams and all of you who implement this. But truly, it's an amazing and exciting presentation. So thank you, Gabby, for putting this together and for being so passionate about this.
And just so you know, of course, Gabby learned a lot from Mayan. And both of them, both Mayan and Gabby, are managing over 300 projects. We're talking about over 180 projects in Uganda, over 100 projects in Malawi. We're talking about many, many, many projects. So really chapeau to both Gabby and Mayan that often time are spending weeks and months in the villages, working with their team, working with the communities. Truly chapeau to both of them. Thank you very much for your commitment. And Gabby, whenever you're ready, it is all yours.
Thank you, Sivan. And I just want to say also, I think that from the community aspect, it's something that we should all be very passionate about. And I know that Gabby is going to provide us with the tools and the background and sort of the knowledge to be able to further our foundational desire to create community-based sustainability And I'm excited to hear what she has to say, but thanks very much for everything that you've said, Sivan.
Okay, hello everyone. Thank you all for the introduction. Sorry, we were doing a little tech organizing back here. Sharon's a lifesaver. Good afternoon. It's good to see you all. Thank you for the introduction, Sivan and Mayan as well. It's exciting, actually. I see all of the different faces here looking at me, and some of you look a little bit tired. I know it's 6:42, so I think we're going to start off by everybody. We're gonna shake it off a little bit and do a little stretching. So let's start. Everyone put their hands up really high. Stretch it out. Don't be shy. It's just us. Okay, now roll your wrists like this. Let it all loose. Let it all out.